Hello, everybody. So we'll go ahead and get started. So what this is basically the first of what we're hoping is a series of these seminars to kind of highlight software that's being developed here at NCSA. So as many of you know, likely we know, we are involved in a great deal of software development efforts throughout campus and nationally, all doing different things with different scientific communities, building different components for data management, for computation, analysis, and so forth. What makes us special in being at NCSA, that keyword, a center, is the idea that we kind of leverage past work, we leverage past experience, we align these efforts to try to amplify them, try to do more than anyone could do by themselves. So the newly formed SSA division, led by Dan Katz, is trying to really emphasize that, trying to bring that focus, make NCSA a center, a focal point for software development activities that we're involved with. And so this is an idea that Dan Katz came up with. His mission is really to try to increase exposure and understanding of what we're doing internally. It's kind of hard to leverage what we're building internally if you don't know what's happening on the other side of the building. And so we're trying to do that starting here today with one of these seminars. And so these won't be as long as a normal colloquium. They'll be probably half an hour in length. But the idea is to try to show you a piece of software, where it's coming from, demo it, and so you can actually see it running. And really get a sense of what your colleagues are doing. So I'm going to hand it over to Craig Willis, who's one of the main developers of the National Data Service effort, which we're involved with. And he'll show you one of the pieces of technology we're developing there called the Labs Workbench. Just really briefly, the National Data Service effort is a mission towards really establishing data as a first-class citizen within the scientific world, trying to set up the infrastructure needed for that. This encompasses a number of things from storage to the services on top of that storage to actually do stuff with that data, and to kind of bring all those together to make it easier for the scientific community to reuse past data. So I'll hand it over to Craig, and he'll talk about the NDS Labs Workbench.
I'm there. Thank you. Thanks, Kenton. And well, there's a much bigger crowd than I was thinking would be out, so thanks for coming out for this. So Craig Willis, I work with Kenton and ISDA. I'm also one of the team members on the NDS project, and I'll say a little bit more than he did about National Data Service for you, those of you who aren't familiar. So the National Data Service and the National Data Service Consortium are kind of two somewhat separate things. So we're operating under a common vision, national initiative towards enabling, publish, find, reuse of digital data collections, research data. Broad goal. There's a core organization, which is director at SDSC, Christine Kirkpatrick, and dedicated staff here, and at SDSC, a small team. We have an executive and steering committee and technical advisory committees that guide the organization, and we provide, particularly on the technical end, support for NDS pilots, and this includes storage and compute resources, and human resources developers to support any pilot initiatives coming out of the consortium. The consortium itself is service providers, publishers, libraries, tool builders, trying to address a range of interoperability issues with data management tools and services, and we're intended to be compatible with the Research Data Alliance organization, and maybe coming a bit more from the service construction, building technical infrastructure, and providing resources. And I'll just note something one of our executive committee members said, that NDS, as it is, isn't really a national data service in the sense of the Australian National Data Service or the Korean National Data Service. There's really not much national support. It's a group of like-minded people and organizations that have gotten together to operate under a common vision. And this is changing, but it can sometimes be confusing that you've got a consortium that's not really a nationally funded effort. And we've got a lot of people here who actually are part of this team. I'd actually asked anybody involved with NDS directly to maybe put a hand up. I know Max is here, Kenton, David, Michael back here is one of the key developers on the project, and the other Michael, or McCall. So that's that. And I'm going to a few slides of context for the workbench. So research data management analysis software, it's a pretty complex landscape. Anybody who dips into this realizes you've got repository and archive software, we've got active data management and collaboration software, we've got data transfer and distributed data management software, analysis and visualization, we've got semantic and vocabulary management services. A lot of these coming out of funded efforts, and it's not always easy to get your head around all of the pieces, and this is really where Labs Workbench emerged. We're in beta right now. There's a public demo at this URL that you're welcome to sign up for just to kick the tires. And This is an initiative that came out of the National Data Service Consortium in 2016 under the guidance of the Technical Advisory Committee and the various committees. It's intended as a community-driven platform to share, evaluate, test research data management and analysis tools. And it's an open platform, so anybody can recommend or contribute tools or participate in the development. So I'll go through kind of the three use cases or the three primary stories that we're seeing. And the first one's the developer, and this is something I think that drove the original vision. So I'm a developer in ISDA, I'm assigned to a new data-related project, and I'm tasked with either learning, evaluating, or extending an existing data-related service. Where do I start? And questions that I think some of us have had, or I've had, what's Dataverse? What's the difference between Dataverse and Clouder? Can I use any of these semantic vocabulary management services in my project? How do I evaluate them? And the common options is I download and install on my laptop. I might provision a virtual machine through Nebula or other cloud infrastructure and try and install and share that software with my team. And from experience, I know I collaborated with other groups here to learn from what they had done, particularly around some of the vocabulary services when I was first hired on. Second story, I'm an educator. I'm a faculty at an iSchool, wants to incorporate hands-on experience with CCAN and Dataverse for their data curation classes for both introductory and advanced courses. And they want a way for students to be able to run the software to familiarize themselves. And both of these happen to be not so trivial services to get set up. And they have varying degrees of technical expertise. So we can ask the students to install on their laptops. We can work with campus or department IT to set up dedicated instruction environments. It's a three-part story. So I'm a PI, and I've removed the names to protect the innocent. I'm a PI for a big data project running a workshop, and I want to demonstrate how research can access and use the data that I've produced as output of this project. I'm on a conference wireless network. I've got 50 participants who need to access specialized software. It could be RStudio or Jupyter with a variety of dependencies, and they need to access non-trivial data sets that won't transfer easily. So I can ask them to install that software and download it to their laptops. I can work with my organizational IT to try and provision VMs with the required dependencies to access the data. I'll note that we did this for the Midwest Big Data Hub, University of North Dakota's hackathon, where we set up virtual machines. That was one of my first tasks when I came here for a hackathon project. 3B, that same project has researchers and developers who need ongoing access to that data, and they also need access to the software required to analyze it or to access it. So again, they can transfer the data and use it locally. We can provide provision virtual machines for them to access it. And then the third story here is I'm the IT or infrastructure person supporting that project. And I need a way to be able to provide constant access to the data set, but I also need to be able to scale up to support, say, 50 concurrent participants at a workshop and scale back down. And we'll say enter Docker. So container technologies really emerged in this space as a nice way of dealing with all of this, and it's a foundational piece of the lab's Workbench system. So we're seeing it increasingly used as a method for packaging and running software where projects are producing this. I think I'll pull up our ISDA poll, but I won't even pull up the results. Basically, I did a brief informal poll of the ISDA team to see how many people are actually using Docker for their projects, and we're at about 80%. So from the technical developer side of things, it's pretty widely used. Of course, they're not very widely adopted, or at least knowingly, by the average user. We're starting to see through projects like the YT Hub, in fact, kind of an innovator in this space, Wholetail, SciServer, people adopting container-based technologies to provide in-place data access for large data sets where you don't want to transfer things around. So it's kind of a low-barrier mechanism to get people in to run notebooks or to run custom software. And it's increasingly viewed as a method of preserving software. So if you're on a grant-funded project that funding is expiring on and you want to be able to continue that software, it's kind of a packaged environment that people can continue to run long after the project has ended. I'm not gonna, that's as technical as I get with Docker here. So over the last year, we've really seen these cases all come together around the Workbench, and whether we address them all or not is be up for discussion, but we now see software packaged as Docker containers, which is enabling us to provide rapid deployment on fairly scalable infrastructure. So we're using Kubernetes under the cover for orchestration and a small cluster. We've got several of these now running at San Diego Supercomputer Center and also here. And we're using it to facilitate education and training for workshops, for students. We're using it to support research and development on large projects. Specifically, I'll go into detail on the TerraRef project in a few slides, and to provide in-place data access, which is another case, enabling people to actually run analysis next to these large data sets. So Workbench, and there will be a live demo at the end here. Scalable platform, web-based. So these are all kind of user interface-based interactive applications. It's a turnkey system for people to be able to deploy from a catalog of data management and analysis tools, really intended for either a personal test environment or a sandbox. This isn't intended to run a service. It's really for exploration or for personal development use. And you can create and upload your own kind of applications as long as there's a Docker image that can back it. From the technical end, we provide, it's effectively console access to all applications. So you get a shell into everything that's running. You've got access to logs. It's not just the interface itself. You can get in fully into the container. So there's kind of the two classes of services that we're providing right now. One is the official workbench.nationaldataservice.org, really intended for either kicking the tires on applications or putting your own applications in the catalog so other people can find it. This is a very, it's officially released in beta, I think, in February. So it's a new service. So you get to promote your tools, and then you can experiment and figure out what some of these tools and services do. And we will gladly accept recommendations of things that you might want to put into the catalog, and it's effectively GitHub pull requests to get in. The second case is hosted or private instances, and so we're working to make this a little bit easier, but to install your own copy of Workbench. And this is really, you want to provide scalable, consistent, cloud-based environments for your workshops and training, or to allow users to launch these environments near data. And that's a newer use case that we're working towards right now. The interface is customizable, and you can provide a custom catalog. So, excuse me. In addition to our primary site, we have kind of two use cases that are active right now. So this is working with David LeBauer and the TerraRef project. And Terra had its own notion of a tool server to launch Jupyter containers and RStudio containers next to 100 terabyte, eventually to be 2 petabyte sensor data set. And in February, we're running a workshop and needed to provide consistent environments for the tutorial and needed to be able to scale to about 50 participants. And this is RStudio and Jupyter environments with specialized dependencies to read and access that data. So we worked with the Terra project to customize an instance of Labs Workbench that's now hosted via their project on Nebula or on Roger, should be, and to develop several custom analysis and development environments that have direct access to the TerraRef data, and primarily used by internal collaborators and alpha users for right now. The second use case is a pilot project that emerged out of the NDS 6 meeting last year, led by Carol Palmer at the University of Washington High School. And this is actually, they'll start using this for her course in early May. And so again, it's a customized instance of the Workbench hosted on SDSC Cloud that's going to provide a sandbox for students to get experience with various data curation systems and tools. So specifically, they wanted CCAN for open data and Dataverse. What's on the horizon for Workbench? So we've got a request from the EarthCube project to potentially, this is, I think it's at least to do an initial deployment of Workbench for them to host building block services. So I think there are about 18 different software services that have come out of the EarthCube project, and they want to at least capture 5 of those so their community can continue to interact with and use those. We've been contacted by the Think Chicago initiative to potentially provide development environments for an entrepreneurial rapid prototyping hackathon/workshop they'll run in July. And we're seeing increased potential use cases, and I've been in touch with groups like Cyverse or the kind of the newer data DNS initiative that's coming out of a variety of national data service collaborators. And this is more similar to the TerraRef case of being able to provide access, analysis environments next to large public or large data sets. And we're really working to enable deployment in more environments, including commercial cloud providers. We're currently deploying predominantly on OpenStack through the various supercomputing centers. And I'll go ahead and plug this. So the NDS Consortium meets twice a year. And interest groups and working groups come out of that. And in this last meeting, last week, was it really last week? There was a small interest group developing around container-based environments for research data access and processing. This includes both these kind of user interface-based interactive analysis environments as well as pipelines. And I know that we've got a lot of representatives here on projects that use this kind of technology, whether it's Knowing or Terra or there are also other groups, obviously, outside of NCSA that do this same work. So if anybody's interested, there's a very newly formed Google group that includes representatives from Cyverse, SciServer, and then a variety of projects here to share information and best practices around this. All right, the live demos. If I can find my mouse. I guess before I go into the demo, are there any questions about the material just covered there? All right, we'll just go with this. So this is the official Workbench instance. It's got a more complete catalog. Anyone's welcome to sign up. You'll go through a brief approval process. And this is, yes, maybe not. So this is kind of our introductory catalog of services that we've added, some of our own choosing and some from the community. So you'll see everything from repositories. We've got CCAN, DSpace, Dataverse on the data management end. You see a variety of development environments to be able to launch, say, Python or Java-based IDEs and to be able to access some of these environments. We've got core components, the Elasticsearch or MongoDBs, iRODS, ICAT, services, and then analysis environments like Jupyter and R. And I think that's about it. Vocabulary services like OntoWiki or Scosmos. And so it's just as simple as selecting, let's say you want to understand what NCSA's ISDA's own Clouder product does. It's just as simple as adding it via the dashboard. We have some configuration options to be able to add optional services specific to the projects. You hit the launch button, and it'll start up a series of specific containers in the background, and you end up with your own private instance of Clouder, web accessible. So, and you can interact with these services as desired. So a similar case, we'll go into the TerraRef project. And so, sorry, I should probably just note, this is a separate instance, so that's our kind of primary demonstration instance. This is customized for TerraRef with its own users and its own catalog. And so we see a Cloud9 Python environment for developing extractors for Clouder, specific environments for kind of their hyperspectral pipeline, Jupyter notebooks, and RStudio environments to be able to analyze and access the data. And this is unique, and it's our kind of first foray into providing direct data access, in that the TerraRef primary project data is actually mounted read-only into every container for users to be able to run against. So this is, in this case, and we've got console access here. So this is just a file system access to an NFS mount that's coming off of Roger, so users can get directly at the data from within. Kind of very low barrier to access, to do preliminary analysis, very resource-constrained environments, but they don't have to, say, apply for VM access or apply for access to Roger to be able to do preliminary work with these data sets. And the final example is the iSchool instance, which is kind of very similar. So we see custom catalog. This is the data curator Workbench. And I should mention that they hope to expand this to be more than UW. They will open this up to any iSchool eventually that wants to do this sort of work. And so we see CCAN and Dataverse and maybe a Postgres UI to be able to get at those backend databases for their advanced courses where they want to provide students with more of an understanding of the core of these systems. And there are more videos available on YouTube that will be available in this slide deck. And I'll just plug, this is all obviously on GitHub, in the NDS org organization. And we're always, I think, anybody involved with the NDS initiative from ISDA is happy to talk about any of this, whether it's the underlying technology or the broader consortium and community. So, 30 minutes.
You think, Craig?
Yeah. We've got a couple of microphones circulating around.
Hello. Hi. I noticed that in the catalog there was PyCharm. So presumably that would be a GUI. How does that work?
Yeah, so this is a less than exciting method. So we were trying to demonstrate here that, yeah, you can, through things like NoVNC or Xpra, actually expose desktop applications. But the user experience of a traditional desktop IDE running in a container via NoVNC or Xpra is really non-optimal. So we've debated taking those out of the catalog, but they're really there to show it can be done. But most everything that we prefer and that actually is viable from a user's perspective is web-based interactives or console-based. So yeah, I'm not going to demonstrate that here, but it's a good question. Yep.
What is the data management solution
What is the data management solution under the solution that based on container? How do you integrate the data into these containers if the data is large enough that the single container is not available?
Sure. I didn't go into the technical details. So we're running Docker, but we're running Docker on Kubernetes. Kubernetes is a container orchestration framework that allows us to scale up pretty easily. Kubernetes actually does a pretty nice job of allowing you to integrate with a variety of storage drivers underneath the covers. We opt for Gluster because one thing I didn't mention is every user gets a home directory, a kind of scratch space that gets mounted into every running container. On top of, you've got your storage for the data that's being produced by the applications. You've got your shared data, and then you've got things like the Terra example, shared data that's mounted in from external sources. So we use Gluster internally that allows the containers to move around from node to node and still have access to the same points. For Terra, the data is actually right now mounted via NFS. But I'll say Kubernetes itself supports a wide variety of different storage options, everything from Ceph to, I'm trying to think what else. You can mount the data directly on the host. So is that what you were asking, Mike?
So I'm more concerned about, for example, managing national data sets, since it's a national data service.
Oh.
So if the data is large enough and heterogeneous enough, what is the common data aspects like data, metadata, catalog, and federated access? Do you have a similar framework like this data workbench or something to?
No, and that's a really good question. So I think it's kind of something we talk about upstairs a fair amount as we work for the National Data Service, but really we're just doing a lot of stuff with containers right now. So at this point, we as a project don't deal directly with the management of large national data sets. Probably the closest thing I can say is the Data DNS initiative, where we're starting to see a lot of examples of research computing centers that are producing large data sets that want to provide access to those data sets to remote users without having to move them around. And SciServer does this, Wholetail will do this, YT Hub will do this, and these are heterogeneous architectures over heterogeneous storage solutions. So there will be, I think it's a pattern that we're seeing that we're maybe trying to share models around, but like our little group at NCSA is not producing anything directly to solve that problem right now. But it's a good, we have not yet ventured into like and I really have to differentiate us from the consortium. The consortium has a lot of activities, but we don't specifically address that.
I don't know if it makes sense here, but do you want to touch on basically what we're doing for Terra, though, for example, as a tool launcher, in terms of running analysis near the data or even the data DNS?
All right, and that's, so I'll go back to the Terra example. So, I mean, this is a way of providing access to a large public data set, or not public, but eventually a large data set. And SciServer does this for multiple domains, different technology. And it's, they've got locally mounted data that gets exposed via interactive container-based applications. YT Hub, and I don't see Matt and I don't see Casper here. I hate to talk for them. Let's not do that one. How about we do hub.yt? So YT Hub has similarly and kind of independently developed a system for launching interactive environments on top of very large kind of astronomy data sets. And I think it's still just NFS mounted. So there's no federated storage infrastructure for sharing this stuff. It's really a lot of heterogeneous services.
All right. Thanks, everybody, for coming. Maybe one more round of applause for Craig.